This fruit going bad so quickly. How to help farmers to preserve fruit for longer?
Hi, I would like to introduce the member of our team. My name is Hai.
And my name is Dung. I'm Đức.
And today I would like to show you the result of our invention. The name of our invention is green biosynthesis of silver nanoparticle using betel leaf extract, an application for the preservation of fresh fruits. During the post-harvest handling of fruits, the losses range from 25 to 60% of the total production. It is due to several factors, and one of the most important factors is the poor handling of the product. Nowadays, people have taken some measures to keep the fruit fresh. However, the impact of those methods is negative, since they are expensive, time-consuming, and may even harmful for healthy people because of using chemicals. Nowadays, nanotechnology has been applied in many fields, and the application that we want to mention is food preservation, and the object used in nanoparticles. There are lots of applications of nanoparticles, but we are interested in petrorecycle, and the signature metal is silver. Betel is a commonly claimed for Vietnamese people and the other Asian countries. It is often used for chemical purposes for its antioxidant and antimicrobial properties. In our invention, we use betel extraction to synthesize the silver nanoparticles.
And now the objectives of our project today. At first, we synthesize silver nanoparticle by using betel leaf extraction. After that, we analyze the characterization and formation mechanism of silver nanoparticle. Furthermore, we tested the antibacterial ability of silver nanoparticle. Last but not least, we come up with the application of silver nanoparticle in fresh food preservation. For the preparation of silver nanoparticle, we use our green biosynthesis method for the reduction and stabilization of silver nanoparticle. In order to do that, we saved the betel leaves and washed it with iron water. And then we grinded it and we collected the plant extract. The betel leaf extract was added to the mix of silver nitrate solution, and then the mixture was stirred for half an hour. The silver nanoparticle was obtained from decantation, and the silver nanoparticle form was 3 times with double distilled water and 3 times with ethanol and hot air in hot room temperature.
We use different methods to characterize silver nanoparticle, such as ultraviolet visible spectroscopy, particle size distribution of nanoparticles, and scanning electron microscopy. The formation of silver nanoparticle was further explained by measuring their absorbance with ultraviolet visible spectroscopy. It showed that the maximum absorbance was found at 411 nanometers, and it was attributed to the surface plasmon resonance of silver nanoparticles. We use light scattering system to measure the size of particles. All dynamic light scattering systems measure light scattering effect arising from Brownian motion of particles in suspension. The nanoparticles are highly monodispersed with average diameter from 10 to 30 nanometers. We use scanning electron microscopy to show the size and morphology of silver nanoparticle. As we can see in the figure, it shows that the nanoparticles observed were predominantly spherical and uniform in size. The silver nanoparticle antibacterial activity was investigated against E. coli and Staphylococcus. The silver nanoparticle exhibited the antibacterial activity against gram-positive and gram-negative and formed the zone of inhibition. To test the potential of silver nanoparticle on preservation of fresh fruit, the sample including pear, apple, and orange were divided into 2 groups. They were sprayed with solution containing silver nanoparticle or deionized water solution and kept at the room temperature. On the 12 days of storage, the control sample developed stains, typically of growing mold colonies, and blotches on the outside of the fruit. Meanwhile, there is no change on the surface of the fruit, which had been sprayed with silver nanoparticle solution. The results show that spraying fruit with solution containing silver nanoparticle can extend their shelf life. In conclusion, we have silver nanoparticle synthesized by using betel extraction. The silver nanoparticle observed were predominantly spherical and uniform in size from 10 to 30 nanometers. The silver nanoparticle show excellent antibacterial against gram-positive and gram-negative. The silver nanoparticles synthesized by green biosynthesis show good potential on prolongation of tested fruit shelf life.
The innovation of our project are first, synthesize silver nanoparticles using fiber petal leaf extract appear a cost-effective, non-toxic, and eco-friendly. And it only requires short-time preparation. And last, the spraying of food with solution containing silver nanoparticles obtained from fiber petal leaf extracts would extend their shelf life. The future work of our study are to study the application of silver nanoparticles in medical, textile coating, and food industrial, and to increase the stability of silver nanoparticles in different solutions.
Thank you very much for your attention.